guys, today we're going to take notes on graphing inequalities with two variables. As always, if you need some more time to copy something down, just hit pause. So you're going to need to write this down, and you know that because the upper left-hand corner has a box that says so. Previously, we learned that x is greater than 3, and we learned how to graph this. First, you put a 0, put a 3, and then it's an open circle. We need everything larger than 3 or greater than 3, and we indicate that with an arrow. Just to review, greater than or less than is open circle, open circle. Also previously, we learned how to graph x is greater than or equal to 3 as well. So we graph a 0, graph the number 3, and we put a closed circle, and we indicate everything larger than 3. Again, we use a closed circle. So things you really need to take away from this is an open circle is for greater than or less than. A closed circle is for greater than or equal to, or less than or equal to. We also previously learned how to graph a line. This needs to be written down as well. As you can see, we have the equation y equals 2x plus 3, where 2 is our slope. So our slope is 2. And 2 divided by 1 is 2. Change in y over change in x. Or, if you rather, rise over run. We also remember that our y-intercept is 3. So when we graph these, because it's an equal sign, just graph with a closed circle. This is totally review. And here we go. Y-intercept is at 3. I go up 2. I go change in y 2, change in x 1, and put another point. Then you can continue with this pattern to graph multiple points. Oops. There we go. Then you make a line. Notice how my line is solid. No big deal. Solid line. This is totally review. We have a solid line. We have closed circles for the equal sign. Again, pause if you need time to write this down. Last night's homework, you guys were given the equation y is greater than 3x, and you had to pick 15 points. You should have seen that all the points above the line were true. So you had a bunch of t's and t's and t's and t's and t's and t's. So everything above here is true. For example, if we were to graph, or if we were to check with the point x is negative 2, comma 0, just to clarify, negative 2, comma 0 is here. X is negative 2, y is 0. So 0 is greater than 3 times negative 2. All I did was plug in my point. 0 is greater than negative 6, and this is true. Also, on last night's homework, you should have realized that everything below the line was false. For example, we can look at the point 2, comma 1, where x is 2, y is 1. Plug it into your equation. 1 is greater than 3 times 2. One is greater than 6, and this, of course, is false. You also should have learned that any point on this line is false. Notice how the line is dotted. And you might have checked with the point 0, 0. X is 0, y is 0. 0 is greater than 3 times 0. 0 is greater than 0, of course, is false too. So we had a false on the line, we had falses below the line, and we have trues above the line. For this part, all you need to do is copy down the equation and the graph. Let's look at the first equation. Y equals 2x plus 3. So we have a y-intercept of 3, and we have a slope of 2. So we went up 2 over 1, up 2 over 1. Notice how they are closed lines. Notice how it's a solid line. Great, no shading. Same equation. We have a y-intercept of 3, a slope of 2. Notice how they are closed circles and a closed line or a solid line. Next, same graph. But look, the one thing that we need to make aware of is that it's an open circle because it's just less than. Open circle, dashed line. We have a point at 0, 3 and a point at negative 1, 2. So for graphing inequalities, the first thing you should do is identify if it's an open or closed circle. It's an open circle if it's less than or greater than open. It's a closed circle if it's greater than or equal to or less than or equal to and equal to. Graph the line with an open or closed circle and also with a solid line or a dashed line. We use a solid line for closed. We use a dashed line for open. Choose a test point that's not on the line and then shade. Please make sure you have those steps written down. Again, hit pause if needed. So let's look at examples. First one is y is greater than 1/2 x plus 4. Well, we see right away that we need to use an open circle and a dashed line or an open line, whatever you want to call it. We also know that we have a slope of 1 over 2, change in y over change in x. We have a y-intercept of 4. So I'm going to put an open circle at 4. My slope is up 1 over 2, open circle. Up 1 over 2, open circle. Open circle, open circle. I use a dashed line. Cool, got a great dashed line. Now I need to choose a test point. My test point needs to be not on the line, above or below. I'm going to choose the easiest one of them all. I'm going to test 0, 0. All right. So y is 0 is greater than 1/2 times 0. Just plugging in my x's and my y's, plus 4. So 0 is greater than 4. That is false. So I know if it's false on this side, it must be true on the other side. If it's true here, you shade above. Shade above. We shade above to indicate all of the points that are true. True. Nice. Take time to write that down. Hit pause if you need to. Your last and final example. So we see that we have the line y is greater than or equal to. Because it's equal to, we used a closed circle, and we're going to use a solid line. We know that we have a slope of -1/6, so change in y over change in x. We have a y-intercept of 1. So first thing, find the y-intercept and use a closed circle. Next thing, use your slope, go down 1/6, 1, 2. Cool. And 2 points make a line. So that's all you're going to need. And with 2 points making a line, be as careful as you can. Now we just need to test a point not on the line. So we're going to test the easiest point of them all, 0, 0. And I'm going to test 0, 0. X is 0, y is 0. 0 is greater than or equal to -1/6 times 0 plus 1. 0 is greater than or equal to 1 is false. So I know if it's false on this side, it must be true on this side. True on this side. So we shade everywhere that's true, because that indicates all of the points that are true for the equation. I'm going to write true nice and big. All right, this concludes our beginning introduction to graphing two variables. I hope you have a great day.